Anton stopped. Okay, I think this is all. Okay, from now it's a Tadi. Okay, let me share. Okay, so everybody can see my screen, right?
Yes, sir.
Yeah, I shared my screen so that instead of the own, I share only one PowerPoint or one of them. I would like to share the whole screen. Then I think we can see it together. Okay, this is chapter two, convolution. Convolution. Okay, so convolution. The integration, convolution integration is this guy. So y of t output, y of t is x of t is changed to x of tau, just change it to tau. And then h of t is changed to h of tau. And then multiply together, multiplication together, x of tau and h of t minus tau. And then integration after, multiplication. So if there's no overlap, no overlap means that one of them is a zero, say the multiplication is zero, the integration is zero. So only overlap area is the integration range of this guy. Okay. So this is the procedure. First step is x of t change it, x of t and h of t is given. X of t is changed to x of tau, and h, h of t change it to h of tau. So all tau domain, and then one of them is flip, one of them, either x or h, one of them, either each one you can flip it, and then shift it, shift the amount of t. So in tau domain, t is a constant. Okay, so now the finding the overlap area, and then in tau domain, and then that's the integration range, and then inside of overlap area, you can multiplication together, and then integration product. Okay, so that's the basically the concept of convolution process. Okay, so last time the what we did is you can see, right? So this one. Okay, see, it's first of all, so if you suppose say x of t, h of t is given same function actually. So either way, either way, one of them you select and flip. So this case is x of t is, just change it to tau domain. So e to the minus t is changed to e to the minus tau, so tau domain. And h of t, it changed to, flip, flip, change it to tau and flip. So h of minus tau, and then shift t. So, altogether, flip, change it to tau and flip and shift altogether. I make it like this, red, red line, right? Red one. So red one is, this case is this t. How you find the t? How you find the t? So t minus tau equal zero position move somewhere. So t minus tau equal zero. Then tau domain, tau equal t. So tau domain equal t. So that this zero position move to t. And because of minus tau, so instead of the this right side, this you go to left side. Okay, so because of minus, you flip. Okay, so this is first step. And then if t is less than zero, then there's no overlap, between this and x of tau and h of t minus tau. There's no overlap. So no overlap means that multiplication is zero, and the multiplication is 0, the integration result must be 0. So this is 0. However, if t is increase, so t is go to 0 over 0, so t is greater than 0, something like this, t equal greater than 0, then we must have some overlap area. Okay, so overlap area is between from this point, the 0 to t. So 0 to t is the integration range. So 0 to t. Okay, and inside of this range, then x of tau is e to the minus tau. So this is e to the minus tau, and this one is e to the minus 2. Originally this is e to the minus 2t. So t is changing to t minus tau. So e to the minus 2 t minus tau. So e to the 2 minus 2 t minus tau. So okay, this one. And rest of them is integration, method of integration in tau domain. So before we tau domain, we can expand this guy e to the minus t minus 2 parentheses t minus tau. We can expand that. That is e to the minus 2t and e to the minus positive 2 tau. So e to the minus 2t is kind of the independent from the tau domain. Okay, constant tau domain. So this equal outside, and then e to the minus tau, e to the 2 tau, combine these together, then this is e to the tau. So integration of the result is going to be this guy. So basically that the concept. This is easy one. So next time. Okay, where is it? Okay, so this one is a similar way. So x of t is changing to x of tau. So right side, 2 times e to the minus t is t changing to tau. So 2 e to the minus tau instead of t. Now this one is minus 2 e to the minus t changing to minus 2 e to the 2 tau. Okay, so t changes to tau. So we have a two function actually there. And now t is simple, flip, change it to tau and flip and shift. So altogether, so if your zero position moves to somewhere, then t minus tau equals 0. So tau domain, tau equal t. So tau over t. And then because of flip, so this is, instead of this way, this is this way, okay? So in the case of red line, then red line, overlap between this function, left side of function, okay? So this is 1 times something, so minus 2 e to the 2 tau. So in the case of t is less than 0, so this is 1 times minus 2 e to the 2 tau. And integration range is integration range is minus infinity to, I'm sorry, this is to the t. I made an error here. Okay, so this is t. Still, I have an error. Okay, so the integration result is this guy here. And then if this is moved further to the right side, scanning to the right side, then t is greater than 0. T is greater than 0. Then there's two ways. One is this function is completely overlapped. So this function is from minus infinity to 0. So this function is completely overlapped, so minus infinity to 0. So this function. And then right side function is overlap between 0 to t. So 0 to t. So, the integration of this. So combine this together, we have this. So graphically, t is less than 0. T is less than 0. We sketch minus e to the 2t, minus e to 2t. And then t is greater than 0. So we can sketch 1 minus 2 e to the minus t. So this is okay, so this is the convolution. Okay, so last time, this is the most difficult part because there are many sections, one of them. Okay, any questions so far? You follow me, right? I don't know whether you are what you're doing. So you better open your video.
Uh, I didn't understand. I'll be honest, I didn't understand
Which one?
some of it. I guess the second example especially,
This
like
one?
yeah, so like um when I was looking up examples online, I just saw that a lot of people would do like four different cases. So I was wondering what would motivate you to do the different cases, and then like on top of
Four,
that,
uh, four
yeah,
different cases, four different reason you mean?
yeah, and then like I guess at the end, what makes you get like the graph that you do, where like it's just like completely different than because
Okay,
it's mainly those parts that are kind of confusing me. Like, how do you get the graph, and then like
okay.
that's yeah.
Let's do it this way. My computer is slow because of communication. Come on, why stay there? Okay, still okay. Okay, so this is given, right? This is given, right? Okay. So first step is first step is x of t change it to tau domain. So every t change it to tau. So far it's okay.
Yeah.
Okay.
Yeah.
And then now next time is this one is change it to tau and shift minus tau and flip and shift. So h of t minus tau. So I will change it to you know look at the only one, red one. Look at the only red one, not black one. Okay.
Now I have a
Uh,
question.
yeah.
Whenever you do change it to the h to the t minus tau, how do you
Uh,
figure out where the t is at for the red one?
all right. So okay. So this h of t. You saw my mouse moving, right?
Yes, I do.
Okay. So h of t is changed to tau, and then flip means that this one is this way. Okay,
I see
this way,
that.
and then you know t is a constant in tau domain, then move. If t is minus 10, you go to the minus 10. If t is minus 100, minus 100, any number
So
is
any
going to
number will
move.
work.
Any number from minus infinity to infinity, scanning. T is a variable.
Now,
Any
if you
number.
had h of t, and let's say it was u of t minus u of t minus 2, and so it was more defined, would you
Oh,
have to, would
don't
you
don't
have to,
don't don't do that. Don't do that. Don't do that. Just graphically, it's a more easier to understand. Okay,
okay.
not equation. Okay,
Okay, I got you.
so graphically, the much more easier. Okay, so I think equation, then you may confuse about it. Okay,
Okay.
so
Thank you.
this is graphically, this is very clear because this is h minus tau. So t minus tau. So t minus tau. So this position, and I would like to use it. This pen, the my pen sometimes work, sometimes not work. I don't know.
So when you're
Okay,
doing the
yeah.
h of
See,
t minus tau, you really just have
look
to
at it.
consider just t when you're working through the problem, correct?
Yeah, this is tau domain. Okay,
Okay.
so t minus tau equal, okay, this position 0. So this position move to where? So this is this is tau domain. Tau is go the other side. So tau equal t. Okay, tau equal t means that this zero position move to t here. Okay, and then because of minus tau, instead of this right side, this is left side. It's okay?
Yeah, makes sense.
Okay. So depends on the t amount. Okay, for example, suppose t equal 10. 10 is this when t equal 10 or minus 10. Okay, or so you can scanning based upon t. T is minus 100, minus 10, increase it, minus 1, and then eventually 0, and then even 1, 2. So t may be, okay, t is less than 0 case. In the case of less than 0, t is less than 0 means that minus 1, minus 2, minus value, for example. Okay, so in this case, the red line is overlap only this part. Okay, this part. All right. So this part. You understand this part? Overlap this part.
Yeah, I get that.
Okay. So in this case, multiplication. X of tau times h of t minus tau. So h of tau is this is minus 2 e to the 2 tau multiplied by this is going to be 1. So the calculation is one times minus 2 e to the 2 tau, and integration range is a overlap area is from this function go to minus infinity, come from minus infinity. So minus infinity to the overlap area is t here, t. So t. Okay. So far it's okay. It's okay.
Yeah, it's okay.
Okay.
I get that.
All right. So that suppose we're gonna move, we're gonna t is increase it. Okay, t is increase it. Go to the okay, t is increase it. So it's a black, like a black line. So t is increase it, then increase it. So eventually t is greater than 0. Greater than 0. If it is greater than 0, it's this function is come from minus infinity. Okay, minus infinity. My pen is sometimes work, sometimes not work. This is very okay. So this comes from minus infinity. Okay, and then the because of this t, black one. Look at the black one. So this function, x of tau is 2 function. One of function is left side from the y-axis, left side. So this function is completely overlap from minus infinity to 0. And then this function is partially overlap from 0 to t. So that, okay, so that this one here, okay?
So from
So-
0 to infinity.
Yeah, 0 to infinity. This function is completely overlap.
Okay.
Okay. This is where's my mic? House. Okay. This is completely overlap. Okay, this function, and this function is partially overlap. So from 0 to t. So integration. Rest of them is integration.
And the h of t minus tau is just going to multiply for the 0 to negative infinity. It's just going to multiply by 1, right?
Yeah, but for one is this amplitude. We assume that one. This is
Okay,
one.
that makes sense.
Okay.
Thank you.
Okay. So if this is a different function, then you need to multiply this and that. Okay.
That
This
makes
case is
sense.
just one. Okay. All right. So I'm glad. I think I think I better change it to. Oops. I don't know. Okay, I'm gonna change it up. the battery of the, okay. Okay. Probably is because of battery. Okay, I give me time. I change the battery. This is okay. Throw away. Okay. Oh.
Okay.
Yeah, go ahead.
For t is greater than 0, why do we use addition instead of multiplication?
T is greater than 0. Why we use what?
Addition instead of multiplication.
Which one? This one here? The this plus? Is it you mean the
yes.
this plus? This plus is a two function.
Yes.
So one function overlap completely. So this is overlap completely, right? And then now next function completely overlap. So because this function is already multiplication is 1, h of t minus tau is 1, okay? 1 times this, 1 times this, so 1 times this is this here. Already multiply by 1, okay? And then another reason in the total integration is the right side of the function. Right side of the function, also h of t minus tau is 1. 1 times this, 1 times this is add up together. It's a total range, okay? Total integration.
Hey,
Okay.
before we move on, I have a quick question.
Right.
Have you had any thought about the test for next Wednesday on the format?
Yeah. We have to do that.
I'm just wondering because, I want to know what I'm going to get myself into.
Okay, well, I think 1 week delayed in even that one. Okay, so now let's do okay, let's do, I discard it. Let's do the, why it's very slow. Okay, see this one. Oh, maximize. Okay, so I think you are interested to look at this guy, right? So this is from. Can you see this?
Yes, we can.
Yeah, this is. I posted a solution already here. Okay, so this is a convolution between x of t and h of t. So h of t is more complicated. So it's just changing the tau. So 1 minus, instead of t, parentheses tau minus 1 to the square. So we just change it to tau. And this one is a flip. Okay, if you flip and shift, then I don't know this. Okay, I will using PowerPoint. Let me see. Let me using PowerPoint.
By the way, I don't think you posted the solution for quiz 7 yet. I don't see it on Blackboard.
I did.
No, I don't see it. You got the solution for quiz 6.
Here, quiz 6. Oh, I did not. Oh, I did. Let me see. Oh, I did not. Okay, I'm sorry. I thought I posted.
It's okay. I was just thinking I was crazy because I didn't see it.
That's me. Okay. So yeah. I promise I'll post it today. Okay.
Thank you.
Okay. Okay. I thought I posted it. Okay. So I think the computer is very slow because the communication between this and the Zoom and I think it takes a lot of time to do that. Very slow. I need the most powerful computing system. Come on, come on, come on. Why it's still there? Okay. Still there. Okay, still falling. I don't know what's wrong with it. Okay, so I will post this one. Then this is no, still there. I don't know what's wrong with this. Okay. I think there's why it so take time.
It looks like it crashed.
I'm troubled. My computer is something wrong. How, what can I do in this point? Can we close it?
The system's probably just overloaded, Dr. Kim.
Oh yeah. Okay, I opened too many things.
Maybe do Control Alt Delete and do Task Manager and close out the PowerPoints if you need to.
Yeah, I just mean main thing is Blackboard's probably overloaded and not letting you upload it while you're running this Zoom.
That makes sense.
It's not easy. So still PowerPoint.
Oh, we're right there with you. It ain't easy. I feel that.
Oh, very slow. Why so slow like this? Okay, I think it's because of a screen. Okay, I'm gonna select the sharing. So sharing is now. I need to open. Okay, so
You see how hard this is? Like you got to make it easy on us because like this online stuff is not easy, man.
Yeah, like what if we take the test, it's online
Yeah.
and we have like a bad connection? That's why we probably should do like a take home, like at least a day. So then if somebody has bad connection, they can still turn it in and do it.
Man, I got 3 people in my house.
No, I had an idea. No problem. No problem. Okay, let me see. Okay, I found out, what can I do? It's close. Okay. I open. Oh,
Also,
I
I'm
open.
stupid, so I need a whole day.
Preach.
Okay, see, now see, I'm bad. I'm back. Okay,
Barely.
I'm back. Okay, so now Okay. Okay, so do you want to do this or the quiz problem?
Yeah, let's do a harder one than this.
Which one? This one?
No, hard. Yeah.
This one?
Let's do the one that you're gonna put on the exam.
Yeah, give us something at the same difficulty level, because if we just do an easy one and we get on the test and it's harder, it's going to make it a little more difficult to grasp it.
Okay, so did you try this one?
I believe so. I don't think that one's too difficult.
That one's an example in the book as well. Like that's the
Oh,
one I
yeah.
was going through, and I was still a little confused because the one on the quiz
Okay.
was a lot different. It looked like a quadratic, upside down quadratic, and I was just like, I don't know what to do with this.
Yeah, the level of difficulty was a lot harder.
Okay. So let me see.
Freddie, you remember where that one was in the book by chance?
It was like one of the first examples. I think, chapter 4, section 3.
Section 3, chapter 4,
Yeah.
section 3.
Yeah, it was either chapter 4, section 3, or chapter 4, section 4. But it was like one of the highlighted examples.
Chapter, you said that chapter 4, there's a Laplace transform.
Or it might have been chapter 2. I can't remember.
Okay.
I got. Let me double
Chapter-
check.
Yeah, chapter 2. You're talking about the Laplace transform, right?
He's just letting me know where that example is shown in the book.
Laplace, I don't know. You're talking about the convolution, right?
Yes.
Yeah.
Convolution.
It should be page 178 or through like 168, like that range right there.
Okay, so do
Okay.
you do
I see it.
this one? This one? No. Okay, 68. 68.
Yeah, page 179 is where it's got it's a pretty good one on 179, honestly.
Okay, so this one. Okay.
Yeah, I agree. That one's a pretty good one.
Yeah, that one's got some funkiness to it.
Okay.
It's a good
A little
one.
funky.
Oh, I think because graphic you confused, but this is very simple case, the simplest case. Okay, so look at this. I will write write like this. Let me see. Yeah, I'm gonna bigger one. Okay, let's do it this way. Let me see. Okay, so this one is one of them. Let's say this is x of t is. Oh, I understand why you feel like a difficult. So this is because this is not from 0. This is 0. This is starting from 1, -1, and then g of t is also. Oh, I understand why you feel.
Yeah, I feel it's difficult because it's convolution.
Yeah, g of t. But
Preach.
okay, this way. Okay, this one, right? You can see, right? Okay, so let's the
Yeah.
Yep.
let's the
That's -2, Dr. Kim. That G of T goes
-2,
-2, and the
Okay.
amplitude is 2 as well.
Amplitude is 2. Okay, so let's say this is exponential function. So let's say 2. Okay, e to d. Okay. Let's do any number. Okay, let's do -2t. Because I think the textbook did not indicate the function here. So just explain about this guy. So this is actually starting from use of t plus 2. Okay. Okay, this is the range. Just this is the range. So you don't, graphically you already indicate that guy. So only you need to concern about this guy. Okay. All right. So let's do this way. This is also minus minus 2. Sorry. I'll write again. Okay, this is very slow. Okay, I will write again. Okay, so this is actually, because this is 2, then 2 times e to the minus t minus 2. Okay. So if in the case of t equal t plus 2, I'm sorry, t plus 2. Okay, so if t equal minus 2, so minus 2 plus 2 is 0, so e to the 0 is 1, so its amplitude is going to be 2. Okay, so let's do the, first of all, what you need to is graphically, you can change it to tau domain. So tau domain is just tau domain. What is that? Low power for continue operation to active pen. Low power, I changed it minutes ago. Okay, so this one, okay, tau domain. All right, so that this is exactly the same thing. So this is minus 2. Okay, so this is 2 e to the minus tau plus 2. Okay, so far it's okay. Everyone understand, right? And now,
Yeah.
okay, now we're going to change it to x of t minus tau. Okay, so t minus tau. So, you need to look at the how this position move, where this position move. So this is position move is, t minus tau. So t minus tau equal minus 1. Okay, so this is t tau equal, okay, t plus 1. So this is the case of, okay, this is the case of t plus 1. So far it's okay? It's 1. It's okay? This is tau domain.
Now for the x t minus tau, why is it going to negative infinity?
So flip. This
Oh,
is
flipping it. You're right.
yeah,
You're right. Okay.
Flip. Yeah,
Makes sense.
because of minus, it changed it to tau domain, and minus tau is a flip.
Yeah, that makes sense now. Thank
Okay.
you.
Okay, so now it's very easy. So this position is less than this position. So first condition is, t plus 1 is less than minus 2. So basically this is
Dr. Kim,
yes, go ahead.
just a heads up, what you're writing is like almost a good 30 seconds after what you're saying. So whatever you're writing, you're talking about something different by the time it shows up on my screen.
Okay, it is different? What?
Yeah, so you're writing. Just,
Yeah, you might just have to slow down, like
Yeah.
Oh,
as,
I
as
see,
you're
I see.
speaking. Yeah, because it's just delayed.
I got it. Okay.
there's like
So-
a solid 10 or 15 second delay between what you're writing and what you're saying.
Okay. So, this was the t plus 1 position is less than 2. Okay, less than 2. Then t is if they're less than minus 3. Okay. There, in these cases, there is no overlap. So, without calculation, my computer has
This is exactly what we see every day.
Oh no. Oh no.
okay, temporarily, let's. Come on. Come on, come on, come on.
Let it breathe. Let it breathe.
I have another laptop, but that laptop is a little faster than this guy. But however, problem is that I cannot use a pen at all. This is the touch screen, so that's the reason I can write down here. Okay, but that another laptop is I cannot write on the screen. That's the problem. Okay, it's a comeback. Okay, so this case is no overlap, so that multiplication is 0, so y of t equals 0. Okay, now I'm going to use a red pen. So if it is move to the here, move to the here. So how much move to the here? So this much move to here, for example. So this is edge is the same thing, t plus 1. So in this case is the t plus 1 position. This position is greater than -2. So greater than -2. Okay. So this is t is in this case is t is greater than -3. So second one, t is greater than equal -3. Then we have overlap. So overlap is from -2 to here. Overlap is like this. Okay, so y of t is integration. So overlap area is -2 to again t plus 1. Okay, in this case is we assume that x of t is amplitude is 1 times this one. 1 times that one is 1 time there is 2 times e to the minus tau plus 2. Okay, d tau. Okay. So this is a result. You can using calculator. You can take a integration of this guy. So t is a constant in tau domain. So you can do what is it? Tau. In calculator you don't have any tau. So just x and t. You can use a t. So if you're gonna using calculator is like this. So integration 2 times okay e to the okay and parenthesis okay and minus x okay minus 2 okay comma x comma from -2 comma t plus 1. Oh, this is integration. Yeah.
Are you writing a range right now?
Yeah, this is range. Okay.
Okay,
This is
okay.
range. So this is function of x. So this is range from minus tau to tau. So this is
What's that
parenthesis
first value in
integration.
your range?
The first value is 2.
Is
2
it
times.
2 times? Okay.
Yeah,
2 times
e to the
Okay.
your calculator has a e function there, blue, e, and then exponential function, okay, and
Oh,
then
you're
raise
typing
it.
it out like we'd have it in the calculator.
Yeah, your
Okay.
calculator has a function, it function, exponential function. So this is, okay, parentheses minus tau minus 2 and comma x comma. So I think you can get the result, integration result. Okay, so graphically what you're going to do is this is minus 3. Okay, minus 3 less than minus 3 0. Okay, and then greater than greater than minus 0. So the result of this guy something, I don't know, it's something like that. Okay, is it difficult? Not difficult.
It can be kind of
Not
too
difficult.
confusing, but yeah, I'm following.
Okay, so I think I understand the convolution is not easy job, but uh, unfortunately you have to do that because you have to understand it. Electrical engineering, as I told before, the convolution and then correlation is the most important function. Correlation is, you recognize object, recognize face recognition, speech recognition, pattern recognition. So that's a correlation function. And system, the processing that is, remove some noise and enhancement, something that is a convolution function. So convolution function is very important for the electrical engineer. So that's the reason you must understand that. Okay, does it make sense now? Okay.
Unfortunately, no.
Unfortunately, no. Oh, come on.
But what would the
I think I'm just gonna watch some YouTube
that
videos.
final equation be?
Final equation. So did you find out this guy? Let's do.
I found it.
My calculator got pissed when I used two variables. I probably did something wrong.
I got
Let me see.
I got e to the minus 4 times e to the 2 times t plus 6 minus 1.
Okay, so let's see. Okay, let's do this one. I can do like this. Integration and then 2 times e to the, okay, 2 times e to the minus, right? Minus, you can do the like that, the x, this is x plus 2. I using parentheses and then gamma, function of x, gamma from minus 2, gamma, t plus 1, t plus 1. You can see, right? You can see?
Yes.
Yeah, this is it. This is you can do that. Sometimes you can combine or.
I got some ugly natural log answers. Anybody got any tips for the mode for this thing?
I think of some mode. Look at the mode or something. I think mode is you need to do that. Or you maybe some other. You can see the mode. Okay. Okay, so this is the integration range. You can combine something. Okay, so in this case, you may combine this person and this one and this one. So exactly. So anyway, this is the the integration result. Okay. So it's okay now. Okay.
I still got something ugly, but it's all good.
Okay.
Hopefully,
if
I'll find it out before the test.
Yeah, if you need, I can I can post the manual of these, TI-89. This mine is the same with my calculator is the same with the TI-89. No difference with the TI-89.
Hey, Dr. Kim.
Yeah.
It might help if you record a video of you walking through one of these problems and upload it to Blackboard, because the delay between what you're writing and what you're saying, and then what we're typing on the calculator, it's not matching up. So I'm struggling to understand the material because of the delay there.
Okay, so how can I do store? Record.
You're using a laptop, right?
Yeah, this is laptop. Yeah.
So your laptop should have
Record,
an app on there that allows you to record video.
Record on this computer. Record in this computer. I think mine is a very, very small memory, but I don't, I'm scared. I don't know. If record. Do you see my screen, right? So record on this computer.
No. I'm not talking about recording one of your lectures. I'm talking about after a lecture, you record a video of yourself solving one of these problems, and then upload that video to Blackboard. That way there's no delay between what you're writing and what you're saying.
That headache for me. I'm teaching, 4 classes right now, and plus, the individual, the two students come from the Korea. They I have to teach separately. So that is a too overload to me. I'm sorry. Okay.
Could you make sure that you post the solution for quiz 7? Because it's going to help with doing quiz 8. Okay, I was just making sure you're going to post it soon.
Oh yeah. I will do right away after this class. Okay.
Oh, I appreciate it.
Okay. All right. Thank you very much. That's it today. So Friday, I'm gonna give you some instruction how you're gonna take a quiz exam. So definitely you need to. I already posted the quizzes. Quiz number 8. Please exactly same with the quiz number 7. You need to submit through the Blackboard, and then TA is going to grade it, and then return back on Monday. And before Monday, I'm going to post the solution also that, and then that is covered. Or that is only chapter 2. Okay.
So is the quiz due Monday or Friday? Friday.
No. Quiz is due Friday. So as you know that Blackboard doesn't accept after deadline. Friday 9 o'clock. So you have to submit before that time. Okay. So exactly the same way with quiz number 7, which Alan instruct to you. Okay. So look at the Blackboard quizzes, and you can find the quiz number 8. Okay. So you need to submit the quiz number 8 before Friday. Okay, you understand? And then that is included in the exam. Okay. Any other question? So Friday, I'm going to give you. I'm going to tell you how you're going to take a exam. Exam is the same thing with the. I'm going to open only 2 hour, something like that. And inside of that time period, you need to solve it and then upload. That's what we need to do that. Okay. Any other question? Okay, that's it today.
All right.
Thank you very much. Thank you very much.